Hi everyone, welcome back. In this video I'm planning to make a project which is about the blurring the faces inside an image. Actually, until now we have learned many OpenCV functions and classes with the OpenCV C++ tutorial series, but it's also very important to use those learnings inside the project, inside the real project. This is also a real project because blurring the faces is a real world example actually, because let's say Google Maps already using that. If you check the Google Maps pictures, pedestrian faces are blurred in there. Also, for some private videos, you have to blur human faces again. So it's a real world example. So we are gonna do this by using OpenCV functionalities. I already requested ChatGPT to generate me a pedestrian included image. So these people are not real people. So we are gonna use this one. We are gonna detect the faces, then we are gonna blur them accordingly. And for this purpose, I'm gonna use coffee model, but you can use any other face detection model. Since this is easy and easy to find from internet, I'm gonna use this. You can also easily get this proto.txt and the coffee model. Just type in the internet, in the Google, it's gonna give you. And here let's start. First of all, we need to create our image, of course, which is gonna be like this. Here all we need to do is just giving the path of our target image. Okay, the next we need to create our DNN network. Okay, CV, DNN and network. You can call it as net. Here we are gonna read the our models. Since we are using the coffee model, we need to read net from coffee. Here we need to give the proto.txt path, and after this we need to give the coffee model path. So our DNN network is already initialized. The next is for each network, this can be TensorFlow, CUDA or DNN is like this. They all need a specific input. For DNN, we need to create a specific blob. We are calling it as blob. So each network requires a different kind of input data. So we need to create it accordingly. So for this purpose, we are gonna use a blob from image. So we need to create our blob, which is gonna be, we cannot directly give the image, we need to convert image into the type which DNN accepts. So yeah, blob from image request an image input. Scale factor can be stay as default, and the size is the most important one here, because as you can see here, my coffee model is 300 to 300, which means my coffee model trained by the images whose sizes are 300 to 300. So I need to give the size, exact size, which my coffee model configuration has. So we need to give here as 300 to 300. Okay, so we already created our blob. Next is we need to set this blob as input to our DNN network, which is gonna be like this. The others can stay as default for now. Our focus is not that. And now our preparations are done for the network. All we need to do is just calling kind of run function, which is forward. And forward is gonna give us a math output, not actually math, but an array, which is, we can call it detections for the, I'm gonna talk about this for the net.forward. This forward actually running the inference behind, and it's just with this forward, actually here already we got the detected faces information data inside this detections for this. So we got what we need for the faces at least. So why for the maybe to talk before talking is more better to print it because this is a 4-dimensional data. So let's print this data each dimension size. So let's talk about it after that. Just copy 1, 2, 3, 4. Okay, so this is done. Let's 0, 1, 2, 3. So this DNA network is giving us 4-dimensional data, and this 4-dimensional data, let's run first of all. Okay, 1, 1, 207. What these are meaning? Let's talk about it. The first one is the batch size, which is we are not gonna use in this project, and the second one is the channel number. Actually, our image is 3 channel, but since we are giving these parameters, we kept it as default with the rest, but it doesn't matter. Even one channel is gonna detect the faces. So the other one, these two are the ones we are interested, because 200 means our network detected 200 rectangles. So it has 200 output rectangles, but we need to filter it out, so we need to get what we need. So for each rectangle inside these 200 includes 7 data. So imagine, so we will extract this also, because we need 200 row and 7 columns. So we need to get this data to be able to use better, because these two are not really important to us, and it's difficult to handle 4-dimensional data. So let's convert these detections 4-dimensional data into 2-dimensional data, which is by extracting these 207. After this, we can handle it easily, since batch size and the channel value are not really important, since we already know them also. So let's focus to the detections 2D, which is can be easily just we are gonna get this one, which is corresponding to the 200. So I want my new data has 200 row and 7 column. Yeah, 7 column, and the type should be float, because we have confidences inside also this DNN output giving the coordinates by float value, so it's important to give as float. And the next, we can get our type as float also, the pointer, I mean the data, so we need to get the data also. And this is basically giving us the, also we can we print? It's okay, yeah. So detections to the okay. So this is gonna give me the output, console output, which is about 200 row and 7 columns, which is all the output DNA gives us. You see there are some zeros, and these are we need to go we need to filter it out again. But let's talk a bit. First of all, this 0 is the image ID. So you see all of those 200 values are starting with 0, because we have only one image, so we don't need to check this part for now. And the second one is true, false. You can think is face or not. There are some rectangles it recognizes as not face, also for us not important. The next other parameters are the most important values for us, which is the confidency. This is the third index is the confidency, and the other 4 is the x, the detected rectangle left top, which is by just x, and the y left top, and this is the right bottom, rectangle right bottom, which is detected face belonging to the detected face rectangle. These are the float values, but all we need to do is just multiplying them with the image column and the row, which is width and height. So it's gonna be mapping into the image pixels. So most of the networks are also giving float values because it's easy. Okay, the next what we need to do is Okay, so we already got, we can remove this cout. So let's create a for loop for each row. Let's filter our images, not images, data. I smaller than detections dot rows. So I want to check each row. Okay, that's okay. Then the next, first of all, we can directly filter by the confidence, because these zero values also are gonna be eliminated easily, because you see all confidence is also 0. So we can, confidence is equal to detections dot add float value, and the ith row and the column is gonna be 0, 1, 2. You see the second index is the confidence value. And yeah, if confidence is smaller than smaller than 0.5, then continue. So we are not interested with you like that. Okay. The next, if the confidence is bigger than 50%, then we can consider it as a face, detected face. Then we need to get our x1, which is again detections, okay, like this. But the third one, which is corresponding to the x1 top left x coordinate times image dot columns, which is gonna map to the image coordinates, because since we are dealing with the x coordinate, we need to multiply by columns, which is width. Okay, and y1 is equal to like this, corresponding to the 4. Of course, we need to multiply by the rows, which is height, and x2. Okay, these should be 5 and 6. Yeah, it's okay. So we got the coordinates. The next, let's create a rectangle. Which is the detected face rectangle. Here we can directly like this, and we can use the point and the size. Okay, point and the size. Point is x1, y1, and size is starting with width x2 minus x1 and y2 minus y1. And we can create a math which is gonna be face row, including the face. From image, give me the crop me the target face, and I want to see each face here. Okay, face and face row. Let's say wait key ups. Okay, now we will see each face, and we are gonna use keyboard to trigger the other one. Yeah, they are detected. Also, it's good to see result and image. I want to draw a rectangle. So we already learned, you see, right? All these functions we already learned. Image, rectangle, yeah. Image, rectangle, color, you know our favorite color, which is yellow. At least my favorite color. Thickness is 3, and let's see the result. You see, why it does not? But I want it to detect this because of confidence, maybe. Okay, now it detects. It's okay. It doesn't detect something wrong. Yeah, we got what we need. The next, we need to blur. We already detected them. Now we need to blur. For blur, there are many Gaussian you can use bilateral kind of, you can use median even, but the most aesthetic one is the filter 2D. So for that one, I want to create a kernel which is gonna be about the we can create CV math, and this can be 15 to 15 by float again, and CV math I want all is ones. You can also check filter 2D function, the purpose of that. If you are using 15 to 15, which is a high blur ratio, so 15 to 15, 15 times 15 is 225, so it's better to use that. So by this we got a 15 width and 15 height kernel. We can call also that image, and each value is 1 over 225, so it's gonna be around 0.00 something. Yeah, we create our kernel also. It's okay, we can see that, right? And let's see how it looks like. Yeah, you see this is equal to this value. So we created our kernel for filter 2D function. Now I want to blur my face ROI. So for that one, I need a blurred, I need a blurred face, and this one is gonna be output of filter 2D. So filter 2D basically accept an input which is gonna be the face ROI, and destination is gonna be -1, and not -1, destination is gonna be the blurred face, and depth can be -1 for now. Kernel is gonna be kernel, the rest is not important for us. And now I want to see my blurred face. Just copy this one, and blurred face, we can call this face. Okay, now we can run it. You see, we got blurred face, which you cannot recognize the people. Okay, now we already use filter 2D rectangle, and yeah, we already use some, I think we already learned about DNN, I think, if I'm not wrong. So we already used these functions which we have learned. The next is we need to put this blurred face to the target place in the image. How to do that easy? You can stop the video and you can think, but yeah, if you already did, the best way is using the copy tool. About the efficiency, about the speed, we can discuss about it, but the easiest and the elegant way is to use copy tool, because it's gonna easily put what I need. This is a bit confusing function, also you need to use carefully. People sometimes also confusing about this, but the usage is very easy. So image and rectangle. Yeah, I said it's easy, but let's say it's working. Of course, anytime also I use copy tool, I'm a bit confusing. So blurred face is gonna be now pasted into my target image. At least I hope so with this one. Let's see result. Yeah, you see now that part is pasted with the help of rectangle, because rectangle knows the target points in our image, main image, so it can easily paste it. Our blurred face can be copied to our image by the target rectangle. Actually, it's done. This was the purpose, but There is a yellow, which one, which we don't want. Okay, now we have successfully blurred it. You can change the blur amount. Of course, not only this one. This is a trick. If you are using 3 by 3, you need to multiply. You need to divide by their multiplication. If like this, it's gonna be looks like, yeah, like this kind of weird things. But if you put 9, now, yeah, you see it's not blurred much. But let's see, before we used 15, let's try with 7. You see it's a bit blurred, not really much. Opposite, if you put something 30, which is double of the first trial, 15 and 900, and see how it looks like. It's really blurred. Also, you can make a bit difficult, not really much, but you can get the landmark of the face by the help of, let's say, if you are gonna use DNN shape predicted face landmark model. So you can mask the face exactly instead of these parts. If you want to eliminate, you can only blur the exact face boundaries instead of some others. Yeah, for this video I think I'm happy because we already got what we need. You see, right, we are learning the functions, but if you combine them as like puzzle, then you can get a target, get a purpose. Now you can check this as simple project, but it's useful, right? Yeah. This video already long. Thanks for watching if you watch until this part, and see you in the next videos.